Your GCSE maths exam is just around the corner, right? Well, let's dive into a rapid-fire revision of the entire statistics section. Think of this as your power-up for the higher-tier paper, covering every single key topic you absolutely need to nail. Let's do this.
So what do you actually need to know? Well, it all boils down to 6 core ideas. We're going to cover the essentials for every single one, from sampling all the way through to scatter graphs. So here's what we're going to tackle.
Okay, here's our game plan. We'll kick things off with the basics of sampling in S1. Then, we'll hit all those crucial data diagrams from S2 and S3. Yeah, including the one that trips everyone up, histograms. After that, it's number crunching time with averages and spread in S4 before we finish up with S6, correlation and causation. And at the very end, we'll do a super quick recap to lock it all in.
First up, S1, sampling and populations. The big idea here is actually pretty simple. How can we learn about a massive group of people or things without testing every single one? Well, you do it by taking a small, smart slice. It's kind of like a chef tasting a tiny spoonful of soup to know what the whole pot tastes like.
It all starts with these 2 words. The population is everyone, every single student in a school, every car that rolls off the factory line. The sample is the smaller, manageable group you actually get your data from. Now, the goal is to pick a sample that gives you a really good picture of the whole population. But, and listen up, because this is a huge deal for your exam, it's not always a perfect picture.
And here it is, the key exam point. You have to know the limits of sampling. The big problem is a sample can be biased, right? If you only asked students in the library if they like reading, well, of course they're going to say yes. But that doesn't represent the whole school. Plus, a tiny sample size could just be a total fluke. Examiners absolutely love asking about this, so you've got to be ready to explain why sampling isn't foolproof.
Okay, let's move on to S2 and S3. This is all about telling a story with your data by using charts and diagrams. We're going to go from the simple charts you've known for years to the more advanced stuff that is pretty much guaranteed to be on that higher tier paper. And I'll show you exactly how to master them. So S2 covers the basics you already know, like bar charts and pie charts. But for the higher tier, the real focus is on S3. That means you have to be an expert on histograms and cumulative frequency graphs. And the #1 place students lose marks, you guessed it, histograms, with those tricky unequal class widths. But don't you worry, we are about to make them make sense.
Okay, memorize this, write it down, tattoo it on your brain. This is the golden rule of histograms. Unlike a bar chart, it is not how tall the bar is that matters, it's the area. So when the bar widths are all different, you can't just plot the frequency. No way. You have to calculate something else entirely.
Now, this is a classic exam table. The first thing you should do is look at the class widths for the height. See? The first one is 10 centimeters, the next is 15, and the last is only 5. They're unequal. That is your giant flashing neon sign that you need to add a new column and calculate frequency density. And here's how easy it is. Frequency density is just the frequency divided by the class width. That's it. So for that middle group, you do 30 divided by 15, which gives you a frequency density of 2. For the last one, it's 15 divided by 5, which is 3. See? Simple. That number is what you plot on the vertical y-axis. Okay, on to S4. Now that we can actually draw the data, it's time to analyze it. This section is all about the calculations we use to describe a dataset, finding what's typical with an average, and figuring out how consistent the data is by looking at its spread. This is where you really start to unlock the stories hidden inside the numbers.
The spec basically splits this into 2 things. First, you've got your averages, mean, median, and mode. They tell you what's typical. You've got to be comfortable finding all of these from a list and from a frequency table. Second, measures of spread, the simple range and the much more powerful interquartile range, or IQR. To get those top marks, you need to know which one to use and when.
So here's the deal. The range is simple, yeah? But it can be super misleading. One single extreme value, an outlier, can make the range massive. It's like judging a whole movie based on one terrible scene. The IQR, though, it's smarter. It only looks at the middle 50% of the data, so it completely ignores those crazy extreme values. That makes it a much more reliable measure of spread. Pro tip: if an exam question asks you to compare 2 datasets, using the median and the IQR is almost always your best bet.
And that brings us perfectly to box plots. A box plot is just a clever diagram of 5 key numbers: the minimum, the maximum, the median, and the 2 quartiles.
They are incredibly powerful because they let you see the median and the IQR just by looking at them. This makes it super easy to compare the average and the spread of two different data sets side by side, which, you guessed it, is a very common exam question. All right, we're on to our final topic, S6. This is where we look at two variables at the same time. The fancy term is bivariate data, but really all it means is we're looking for a relationship between two things, like how ice cream sales change with the temperature. You'll plot this kind of data on a scatter graph. Now, you've got to be able to just look at a graph and describe what's going on. If the points generally go up from left to right, that's positive correlation. Think, the more you study, the higher your grade tends to be. If they go down, it's negative. Think, the more time you spend on your phone, the lower your grade. And if the points are just all over the place, there's no correlation. Simple. Then you'll draw a line of best fit right through the middle to show the trend. But you have to be careful with making predictions using that line. If you make a prediction within the range of the data you actually plotted, that's called interpolation, and it's usually pretty reliable. But if you extend your line way beyond your data points to make a guess, that's called extrapolation, and it's really unreliable. You just can't assume a trend is going to continue forever. That's a key detail examiners are always looking for.
And now for probably the most important sentence in all of statistics. Just because ice cream sales and shark attacks both go up in the summer, that's a positive correlation, it does not mean that buying ice cream causes shark attacks, right? That's insane. There's a third thing, the hot weather, that's causing both. Please remember this phrase, it's a guaranteed mark winner.
Wow, we have covered a ton of ground. So let's boil it all down to the absolute must-know facts for your exam. This is your final power-up. Ready?
Number 1, sampling has limits. A sample might be biased. 2, for histograms with unequal widths, you must calculate and plot frequency density. 3, use the IQR, not the range, to measure spread when there are outliers. 4, use box plots, specifically the median and IQR, to compare data sets. 5, use a line of best fit for predictions, but do not extrapolate too far. And 6, say it with me, correlation is not causation. You've totally got this.
Look, you've got the tools, you know the tricky parts, and you have a clear strategy. Now go out there and absolutely smash that exam. You've earned it. Good luck.